Hey everyone, very good morning. Hey Mayuk, good morning.
Yeah, hi everyone. Good morning. I hope I'm audible.
Yeah, yeah.
Yeah, yeah.
All right. I
Good morning.
guess we can start, or shall we wait for a minute or two for
I
people
think
to
we
come?
should wait for 1 or 2 minutes because it's almost like the half of it, or
Yeah, right,
two
right.
third.
No,
Yeah.
I understand it's Sunday morning, 10 o'clock, so probably a couple of minutes is fine. Yeah. All right. I think we can start now slowly. Okay. It's 5 past 10. Yeah. Anyone wants to say anything? I see Venkat's hands raised.
So, Mayuk, you asked me to remind you of one of my doubts yesterday at the start of the session.
Yeah, right. And what was that, to be very honest, if I forgot. That's why I told you to remind me.
So that that is
Yeah.
the data leakage that happens if we consider the y values when doing
Uh,
the class specific imputation.
okay. Yeah. So yeah, I think I remember now. So I think I told this that in the context of scaling and all that, we'll discuss this, right? About the leakage part, right? Uh, okay. So let's start with that only. I think we are kind of logically in that place anyway. Uh, so I think I asked yesterday, and all of you confirmed that you have had discussions on feature scaling as well as splitting data into train and test. So that those are two concepts in an isolated manner, at least, is you're aware of, right? Uh, so now let me ask you a question, okay, and then we can probably kind of take the direction of the discussion from there itself. Uh, do you think scaling should be done before splitting, or do you think scaling should be done after splitting?
After splitting to
After
avoid
splitting.
data leakage.
Okay. Anyone else who has any idea, I mean, any input on this, and in addition or contrary to what Venkat says?
After.
After, right? Now, okay, after splitting, you do scaling, which is, I think, as you guys understand, it's to avoid the data leakage. Because what happens if you do before scaling is that then you are using uh, the mean and standard deviation. If you say you are doing a Z transformation, right? Or you are doing a standard scalar, you are taking the mean and standard deviation and essentially for the whole data and then doing the scaling, right? Before, if you do before split, and that in that way you are embedding some impact of the test unknowingly, or rather knowingly, if I put it, in the train, and then hence you are when you're trying for overfitting, or when you're trying to test your results with respect to test, at that point it's probably not completely unbiased, right? So that essentially is the point of doing it uh, after scaling, after splitting, right? Now, one mistake a lot of people do even after splitting also is that they still do the fit transform when they do the coding, right? They still do the fit transform separately on train and test. On when they do the splitting, when they do the scaling after splitting, they do it separately using the train and test. Okay, you should not be doing that. You should be doing the fit on the train, get the mean and standard deviation from there, and then use that one to transform both train and test. Okay, because if effectively when you're scoring your models, right? I'm going into models. Sorry, I'll not stick around into that too much right now. At that point, it should be the same relationship in terms of how you are taking the coefficients or parameters from a model, from the train model to a test. So that is why that is also something critical, which I'm sure you will learn more about it when you build models. So maybe a little premature in that respect. Uh, but coming back to your question, uh, see, the whole idea of this leakage and even the scaling part as a part of it, right, is more of there are two groups of debates these days. If you go to the industry, if you go to talk to people who are building the models really, right, there are two sets of theories. The one set is obviously doing the scaling, splitting before scaling and dummy variable. Sometimes I'll come back to why it should be done before dummy variables or the encoding part, right? The other school of theory sometimes is that do it as early as possible. Okay, do it as early as possible means you look at your univariate distributions, you look at your whatever bivariate distributions, and then before you do any manipulations, any feature engineering for that matter, encoding, scaling, anything, right? You do well advanced. So you do it separately on train and test, and then that involves a lot more work, obviously. But that's a school of thought, because in some industries, in some domains specifically, if you go to telecom, for example, or if you go to manufacturing, for example, maybe in others also, here I know in these two, uh, the the gestation period is what we call the gestation period for a model to be sustainable in the pipeline of production, right, is a little less than say what it is in hardcore retail or FMCG. Okay, and that is generally why they are a little more cautious. Their p-values are taken at 0.01. Their multicollinearities are done at VIFs at 3 rather than 5. So all those things, all the regulations are a little stringent, little more, I would say, rigid in that sense, because they see that in production things fail very quickly. Okay, so it's basically empirical evidence kind of also drives this. Now, specifically to answer this, why we should be doing splitting before, say, doing a lot of work, especially the feature engineering, the encoding and all. What happens is, by the way, all of you are aware of encoding, dummy variable creation and all that. Otherwise, this will not make a lot of sense.
No, no, Mayur.
No,
No,
currently
right?
we are not aware.
Okay, okay,
No.
okay, okay. Okay, then I'll not get into that, because then this will be a little, I would say, out of context anyway. So then, Venkat, your question, shall we take it separately?
Yeah, sure.
Yeah, that would be better, I guess, because otherwise it would be a little irrelevant here. Yeah. Okay, did I miss anyone's question from yesterday evening? I will take today's questions at the end, but if I missed anything in the chat, maybe there is a possibility I missed, that I will try to address now, and then anything fresh we'll do maybe last 15 minutes or so. I don't think I missed a lot at least, but if anything, just let me know.
I think we can go ahead with the new topic. Yeah.
Yeah, I don't think there is a lot of misses. I just try to be doubly sure. That's it. Okay, so what I'll do today is that I'll try to, I'll not get into ML models at all. I have a agenda in terms of, I will show you a couple of quick slides on different EDA techniques for on the basis of industries to an extent, where say I've taken 3 or 4 major industries where that I'll show you, and then towards the end I'll do a little bit of discussion with governance and ethics, which is again very topic driven and kind of, I won't say boring, but yeah. Anyway, so but before all that, since you haven't done models, at least some of you, I'll try to give you a sense of why, a little bit of introduction to linear regression, because that's the first model everyone does, even if you haven't done anything before. The reason I'm doing it, I know that you will do it later and all, to make a full circle meaning of EDA, it's very important that you have some idea of a model. So when I generally do my EDA sessions, right, if I do a full-fledged EDA session and the machine learning, I mean, if I do ML, I always do EDA. I don't give it to anyone else because it's important that the same person does it. The first day of EDA itself, I introduce linear regression because I think it's a little important. It sometimes becomes important. I didn't do it before, but over the years, I've realized that that gives the person who is doing these things for the first time a little more idea of why they're doing what they're doing. Otherwise, what sometimes happens is that I'm telling you, you have to do scaling, you have to do transformation, you have to do dummy encoding, you have to do something else, right? Now, the question that sometimes comes to mind, at least to my mind, is that why the hell will I learn all of these things? Where is the application, right? So that's where the some context in terms of where this leads to in the entire spectrum of the model building is very important, right? So that's why I'll go a little bit into it. I'll not get into any model as such, just the idea so that this EDA makes a bit more sense from that perspective only. Okay. And then I remember, I think I also said that will do a EDA stepwise thing, right? What to do after using perhaps a bit of a coding, right? That also I'll show. Won't take much time. Let me go back to the sheet we were using yesterday because that is easy to kind of connect to that. Yeah. Or I have probably, no, I'm showing something else, sorry. Yeah, this should be the one, right? We were doing yesterday.
Yeah, yeah.
Right, yeah. Okay, so let's look at, I'll just give you, as I said, I'll spend just 10 minutes on this. Again, many of you will obviously know this. It's not going to be new for a lot of you. We'll write something like this, which is something I'm sure all of you know, right? Y equal to mx plus c, which is a usual straight line equation, which we learned in our school days and all that, right? In our high school, if I'm not wrong. So this, okay, can quickly anyone, I mean, I'm sure all of you know, quickly anyone, what is x and y here? Sorry, m and c here, rather x and y, m and c.
May
M
I?
is
M is
slope,
activity.
M is slope,
Slope and C
and
is the constant.
Intercept or
C is
constant, right?
intercept. Yeah.
So
Yeah.
Intercept at y-axis.
Let's give it a meaning. Okay, let's say y is my consumption on food, okay, or consumption or spending on food. Let's put it this way. Say monthly spending on food, okay, and x, let me say, is monthly income. Okay, very easy example. Now, obviously, how I get the m and all, it's more statistical. I'll not get into that. You will learn that when you do regression. That's not the point now. Let's say I have a value of m, which is say 0.2. Okay, the slope value, of course. If you draw a diagram, you get that value, is 0.2. Intercept, I'm not taking for now. We'll come back to that. Right now, say it's any constant value, doesn't matter really. Okay, so if I say that, say there are what 120 odd people in this session right now, right? Now, if I say, obviously this is a far-fetched idea, but say for the sake of argument, let's say that all of us, or at least half of us, maybe any 50 of us or 60 of us, have a monthly income of say 1 lakh rupees. Okay. Now, if that I fit in y equal to mx, okay, then what happens? I can say that all of us are having a spending on food, which is 20,000 every month, right? From this equation.
Yes.
Is that possible? Is that practical?
No.
No. You forget 50 people. That's not practical for even 5 people, right? You can still earn the same amount of money or similar amount of money, but spending exactly on the same amount of money is not possible, right? That's not never going to happen. So this y equal to mx plus c, the one-to-one correspondence that we so innocently believed when we first saw this equation in our life, doesn't hold true in this form. At least we have to do a bit more improvisation on that. Okay. Now what we end up doing is we say, Ajay, before that, the role C plays in this equation at least is that in a particular month, if I don't earn money, that doesn't mean that I'll not eat, right? I'll have to still spend on food. Right? I have to keep on eating, right? So given that this is my subsistence in money that I need for spending on food, I'll borrow, I'll take up from, I mean, I'll take from my banks, from my accounts, maybe borrow from my family, friends, whatever it is. But the point is that this C is my subsistence level of Y when the X's are not having any impact on Y. As simple as that, right? Or not existent in this form. Now, the moment I put it the plus E, right, which is error, or you can say residual, at least at this point, they're same. There is a subtle difference, which is more statistical, not relevant right now. So when we add the E generally takes care of two things. A, it accounts for absence of other relevant variables, which essentially means that I am only trying to understand my spending on food on the basis of income, right? But there can be other things, number of loans I am paying, number of dependents I have at home, my other demographic features that I might be part of, right? So all these variables are not part of this equation at this point. So E is kind of playing or giving a proxy for them, right? It's kind of trying to balance the MX plus C with a Y. Say people from anyone who is a commerce or a costing or a CA background will know that there's a thing called suspense in trial balance accounts, right? I read long back. Anyone saying anything, but your voice, I think, is, yeah, didn't quite come through. So this is more of the absence of other relevant variables. The second part is basically psychological factors. Okay. Now here I can see in the panel, I can see Vinod's name just coming after my name, right? So say, for example, I am very fond of having biryani. I want to have it every single weekend, right? Now, that will not do a lot of help to my health, but I still go ahead and do that, right? And say Vinod is very fond of something else. He's fond of Punjabi food or Chinese or whatever, right? Now, that psychological factor or the individual choice essentially will play a role which I cannot really quantify using this equation, right? So I cannot say that when I'm doing a generalized value of M and C from this equation, I will kind of incorporate the psychological factors or individual preferences in that. That's not going to be possible, right? So the E is in a way, it takes care of these two things, okay, or is kind of encompassing these two things, which this equation is devoid of at this point, is incompetent in terms of figuring out, right? So this equation, what you see here, when we add the E and make it balanced in the right-hand side and left-hand side, is nothing but the linear regression equation. In the simplest form, with one X variable and one Y variable, it is a linear regression equation. Now, what happens in this equation is that I'm trying to use the X to explain Y. Like we were discussing a little bit yesterday about spurious regression correlation around that time, right? With that example of ships going down and all that. So in that kind of a case, that person in that university was trying to have a lot of excess of the weather conditions and trying to understand the why, whether ships will go down or not. Now, in a linear regression equation, this Y is my target variable, okay, or the variable of interest. You can call dependent variable. There are plenty of names really. The X's, here I have one X. As I said, there is obviously going to be a possibility of multiple X's, many more variables potentially having an impact on my income. And then I will have a M1, X1, M2, X2, M3, X3. So individually, they'll have their slopes and their individual impacts on Y, right? So then the equation keeps on going and getting added in the right-hand side. And then, but Y remains same, or Y remains 1, because that's what I'm trying to understand using all the X's as a group, essentially. They will have their individual effects, but I'll try to understand it from a group. Let's say we have another example, say sales or revenue. Say revenue, I can write it revenue as well. Revenue of a company is Y, and I have X's like say cost on advertising, cost of marketing, right? Maybe R&D cost or something like that, right? Usual, the industry and the kind of variables we have. Now, these are costs that has happened. R&D cost, marketing cost, advertising cost, and plenty of things. So these become my X1, X2, X3. And I'm trying to understand, say, a revenue at the end of the year, that how these are having an impact on the revenue. Okay, so that whatever I have spent on advertising, how much it has accrued to the revenue, or how much the marketing spends or the marketing initiatives have accrued to the revenue, right? That's what the business wants to know. Otherwise, how it will budget for the next year, right? So this is where the regression framework comes in. In a linear regression, my target is continuous. Continuous means it's not a discrete data. It will be profit, sales, price, those kind of variables where it can take any value in its range, right? A continuous variable. When you go to classification, this becomes categorical. That's the only difference. But anyway, we'll not go into classification at all at this point. So this is the easy or the simplest way of understanding the equation of a linear regression, or the framework of a linear regression in that manner. Okay. Any comments or any questions on this from anyone? Okay, all good. So given that, this I wanted to tell you, because if I am building my EDA, like we were discussing certain elements yesterday, say outliers, say missing values, right? For those kind of things, if I'm doing it for my X variables, essentially, more or less, right? If they are the more in number, right? So if I'm doing for that, at the end of the day, see, how am I going to use them is very important, right? So I'm going to use all this excess in terms of explaining, or in terms of how efficient they are in explaining why. I am not here to judge on the excess. Okay, I'm not here to understand how they are or how bad or good they are in terms of their values, right? I am more inclined to understand how they might, or how best they can impact my why. And that is very important. I need to know this, and that is very important to keep in mind when I start my EDA, or when I start my analysis of individually all this excess, right? Because at the back of the mind, I know how they are going to be used. So I'm not necessarily trying to draw univariate distributions or bivariate distributions to essentially repair things in this X variable, or make things better for the X variable. That's not my aim. I am trying to do all of this so that this can be a better explainator, or better explainable quality it has in terms of why. That's always my aim, and that is very critical when I'm doing the distributions of the diagrams as well, right? This has to be very, very critically followed. Now, given that this background, as I said, I just wanted to add it from the EDA perspective itself. One question, okay, think through and let me know. If I have, say, let me write it down also here. If I have 50 variables, okay, in my data, I have 50 variables. Now, obviously, if I know now that how machine learning equations are formed, a regression kind of equation, right? I know one of them. One is target, which is my Y. And potentially, obviously, right now, I don't know who is good, who is bad. Potentially 49 are independent variables, right? Indep-var. Okay. This is my setup. Okay. Now I'm saying that obviously in the EDA, one of the questions a lot of people face, and one of the conundrums a lot of people face, is that I know how to draw a box plot, I know how to draw a scatter plot, I know how to draw a histogram, and plenty of other things, right? But what will I draw in a particular data for a particular problem? What will I draw and what will I not draw? Okay, that is very important, because just because I know a lot of diagrams and I know I have a lot of variables in hand, I'll not keep on drawing. It's not a drawing competition, right? So I'll not keep on drawing diagrams. So I need to have a logical way of assessing that what kind of diagrams, or what limit, or what level of diagrams I must draw. Now, in this example, okay, think through and tell me what is the minimum number of scatter plots I might be drawing, or I should be drawing. Bivariate plots, basically, which is scatter plots. What is the minimum number I should be drawing in the first cut, at least, if I have this as my input?
49.
49.
No,
49. Okay.
it
Someone
depends,
saying something
it depends
else?
on the number of numerical values you have and the categories that you have.
Say for example, all of these are numerical. Okay, let me make it easy.
Everything is numerical.
Yeah, all 50 are numerical. Then what? I have heard 49 from a couple of people. Anyone else has any answer?
Also, we would be drawing some to identify the correlation between the
Hmm.
independent
Maps
variables.
to give the correlation, and based on the correlation there, maybe we can decide how many.
Yeah, that is the logical way to do it. But I also like the people who said 49, because that's the right way of thinking. Okay, in terms of that, assuming that all of them are potentially correct variables, right? The reason is
I can show these 49 variables on a heat map, though if I will go one by one, then obviously 49 will be required.
right. And also, I think I saw what I think one of Venkat wrote, right? That there is one pair plot which will do it, right? In terms of 49 scatters, if you want to do. See, yes, one pair plot will do it, but
variables.
sorry.
Pick the continuous variables, the ones that
Yeah,
are continuous.
I am saying here all are continuous for the sake of argument or simplicity. No, I like the way you said 49. Again, obviously you can do it in pair plots. That's not a problem. But why 49 is because you would ideally see the main aim is not the number. The main aim is what you want to achieve at the end of it, right? What you want to achieve at the end of it is that every single X variable should be pitted against the Y. That is what you want to at least go. No, right? So that is why this 49 diagrams, be it in a pair plot, be it 49 different scatters and all that's a separate thing. But that is important to do. Now, again, as some of you, I think, pointed out, and very rightly itself, that before even I do this, I should be checking correlations, or I should be checking relationships in a different way, probably heat map, probably correlation coefficients, right? So that this 50 itself or 49 diagrams itself can be brought down, can be reduced, right? But the logic remains same. If I am reducing in that way, then I again use the same logic. If it is left with 20, 30, doesn't matter, right? But the logic is that whatever variables I'm going to take for my scaling or dummy, or here to dummy not relevant, but scaling and other things afterwards, the feature engineering and everything, I should be having a sense that how they are affecting my Y a lot before that. Okay. Now that I know I'm trying to do all of this for a model, right? Because if I don't do that, I'm going to do a lot of extra work. Also the other I would say advantage of doing this, or other input you can get from this, is that when you do the regression, or when you try to fit this equation later on, right? This equation later on, and you get coefficients, all the m values for the individual x's and everything, right? At that point, you can always come back to your correlation here, the heat map and the scatter plots and all the correlation coefficients you drew maybe after or before. And you can also think of, or also kind of corroborate. You can say that, okay, is it mapping? Is it matching, right? Or am I getting a different input in a regression setup, or a different result in a regression than what I got into a one-to-one individual correlation, right? That is possible sometimes. So that is another way to understand a variable's behavior in an individual one-to-one relation to a multivariable equation relation. Okay. So in that way, this is quite important that we do it thoroughly. It's not because sometimes what people do is that out of 49, yeah, I can get a hunch that maybe 20, 25 are important. The others are not necessarily important in the context, and leave it out. Yes, if you have superb domain knowledge, it's fine. But that is a risky thing to do unless you are 100% sure. Okay,
Maybe
so
from here onwards, one-to-one correlation is required, or we can straight away go down to sparse matrix or the PCA approach.
no, I think PCA, Tarun, see, PCA is okay, but one of the problems with PCA in general is that it will not give you a lot of driver information post model, right? Not a lot of driver or X variable information, right? Because in PCA, what happens, every principal component will be formed using all the variables, right?
Yeah.
So I mean, you cannot segregate their impact, and that is a problem sometimes depending on the business statement or your problem statement. If it allows, it's fine. But if your problem statement says that you have to have individual impact, right? Then PCA is actually not a very good method, to be honest. It's a very popular method, I get, but not a very good method in that sense. So we have more dimension reduction methods coming up these days. SVD is there, TSNE is there, which is the new thing which is coming up very quickly. TSNE is t-stochastic neighbor using t-test, statistical method mostly. So these are slightly better. Even factor analysis sometimes works a little better because it uses a regression in the back end. So those are there, but PCA is
Just I will ask one question maybe at the end of this one,
okay.
that is not maybe not relevant for others. So yeah. So
Okay, no problem. You can ask in the end. Yeah, sure. So this was more. So that's what I said, that when you are drawing diagrams, because we often say that when someone is given a case study or you're getting into a project, right? It is often said that do univariate analysis, do bivariate analysis, multivariate analysis. It's easier said than done. Someone will say that and go. Then I have to figure out how much what I would want to do, how much diagrams, how much individual relationship assessment and all that, right? So for that reason, it's very important that at least the minimum thing I kind of achieve is that I try to understand the individual impact of the access on the Y. If some of the X's are connected, I feel from the variables that they are connected, they will be very strongly correlated or collinear. Then of course I have to do their relationships as well. But this is the bare minimum. Yeah, Venkat, you want to say something?
Yeah, so you have mentioned TSNA, right? So for that,
Right.
I've read that it is only to bring the visualization perspective in lower dimensions, and it is
Yes.
not used to downstream machine learning tasks. But
No, it is not used to downstream machine learning task, and that is precisely why I would use it sometimes, because I don't want to downstream machine learning task.
okay,
I want to do the visualization, as you said correctly, right, in terms of features and bring them down there. So it helps in more in the dimension management in the EDA than in the ML. But if I do the dimension management better in the EDA, then ML automatically becomes a lot simpler.
but we are trying to create a 2D plot based on the by preserving the distances in the higher dimensions. How will that give us any uh, EDA perspective? Like, how can we use that knowledge in our model?
Okay. Shall we do it again separately? Because this will be a discussion way away from all this.
Yeah, sure.
Yeah, because people who know model will get it. Otherwise, it's just miles above the head. Okay, but yeah, your question is valid. I know where you're coming from. We'll take it separately. Yeah. Okay, so this was one thing I wanted to think. I want also you to think. It's not that what I'm saying is always the gospel and will work for every data or every problem. Nothing works in every data, right? You will also always have to be innovative with new projects every single time, right? So, but again, these are some ideas which will probably help you through get more insights or more kind of and broaden the horizon given a new data or a new problem that comes in, right? One thing I would also like to do, I'll show you a different data set, which I accidentally shared the last time, and I will explain what it is, and then I'll have a question on that. Yeah, this one. Okay, this is a very easy data, nothing there. These are the variables. Okay, let me highlight it. Yeah. So this is the customer data for an online marketeer. Okay, so this person is selling stuff online, say furniture or something. Okay. And this is the customer data that person has. Okay, the age of the customer, gender of the customer, whether they have a own home, whether they're married, location. I'll come back to salary, number of children they have in the household, history of buying, the frequency in the last 1 year. Catalogs is the number of catalogs or product list I have sent to them over email in the last 1 year. Amount spent, obviously in dollars, how much they have spent on my product in the last 1 year. And location far close basically is that whether they have a competitor's physical store far from their home or close from their home, depending on a threshold, right? So obviously, if they have a competitor, if I'm selling furniture online, and if one of my customers has a furniture store next to his house, right? Obviously, they'll go and probably look at there and then rather than randomly placing order on my website, unless they give a massive discount, right? But if someone has to travel 5 kilometers in a car, bus, auto, something like that, and then go and buy, they might prefer to buy it online, right? So that's why this far and close can be very relevant here. Now, this is the data given. Okay, this is the data given by the online marketeer. Say you are the data science person or you are the data analyst. Okay, and this data is given to you. And obviously, the online marketeer is not a data expert, right? So they will say that give me the best, analyze this variables from my customers and give me how my business will be benefited from this. So they will always have this kind of a statement, right? They will not say that this is your target variable, you build a model on this, right? They will not be able to tell that. Now you tell me, logically thinking, not by hunch, from the 10 variables or so which are there, which should be my target variable?
Amount spent.
Amount spent.
Amount spent. Anything else is possible, or do you think it has to be only amount spent?
Salary.
Sorry, which one?
Salary.
Salary. Okay.
There is age and location
Yes.
because
Okay.
we have more of middle and
History.
people, so we can target that.
Okay.
I guess
Someone says history.
location
All right.
and
History is good.
Okay.
Maybe we can form clusters out of it and label the clusters by studying them and try
I
to.
am not even going into all that. That is separate. I'm just saying that I'm trying to find what to target first. Which
Okay.
variable is my independent? Why? in that context I just said?
History.
History. Okay. A lot of history, a
Gender
lot of amount
specific?
spent. Huh?
Gender specific?
Okay. I think I have heard everything except customer ID, right? Yeah. See, think through. Okay. Don't randomize. Okay. Think through. Now, see, if I'm doing this model for the online marketer, right? Now, let me look at the first 1, 2, 3, 4, 5, 6, 7 variables, which is from age to children. Okay. Now, these does the marketer or does the business owner has any say on any of these 7?
No.
Can that person go and change the gender of a person? Can that person forcefully get someone married? No, right? Or can that person increase or decrease someone's salary? No. So he or she is not essentially impacting any of this. This is purely the customer's data, right? So will he or she be benefited by predicting any of that?
No.
No. What's the point, right? Now let's look at catalogs. Catalogs is something this person is sending over email, right? This business person is sending. And it can be 6, 12, 18, some values you can see, right? In multiples of 6 effectively. Now, this is something the person controls. If I want to send 6 catalogs in 6 months, I can send. If I want to send 1 catalog in 6 months, I can send, right? This is a variable if this person 100% controls. Do you think there is any point of predicting this? Do I want to predict my actions which I control 100%?
No.
No, doesn't make any sense, right? I'm left with history and amount spent, which both qualifies. History is categorical, amount spent is numerical. They effectively say the same thing. Probably amount spent is a little more preferred because it's easy to deal with and more monetary in direct sense. But these work. Okay, these can work, both of them. If effectively, generally amount spent will be the proven choice, of course. Now, why I showed you this example, not to hear random answers from everyone, but the reason is when this kind of data sets are given, right? Because the business will find a lot of data sets. And I'm sure all of you also who are working in using data and different data-driven business calls and all that, right? Sometimes the problem is to form the problem statement itself or to get the right target variable in terms of what the business wants. That's a big problem in many cases, especially when you're dealing with client data, right? The obviously what I'm going to say is not a foolproof thing. It's eventually what it has worked for me over the years, and I kind of get a good sense out of it. I will see the first 7 variables in this example are variables which I means the person who is trying to build the model for the business or the business itself representing the business. I will not control at all. My control is 0. Catalogs is a variable, my control is 100%. History and amount spent are 2 variables where my control is partial, but I want more control. Can I say these statements?
Yes, that's correct.
Always my target variable, you will always find, even if someone gives you 100 variables, you will always find only 1 or 2 where your control is partial, but you want to increase it. And always, every single time, they will be your target variable, not the other ones, the zeros and hundreds.
Mayuk, amount
Yeah.
spent is no control, right? Not even partial control.
I do control, right? Given the price I'm setting, no?
Yeah.
I do control to an extent. Even history, I do control, right? In a similar way, right? But again, the control is very limited, right? But I want to increase it. Now, how can I increase the control? By understanding how the other things, how these first 7 variables, for example, are having an impact on the present amount spent. If you understand the age, in terms of age, say a middle group or an old group, maybe the gender, say a female, or say people who are owning their own home, people who are married. So I can essentially scale through all or kind of skim through all these variables and get the best kind of all these variables, the best combination, which is giving me the higher amount spent. So eventually what happens, they are my best group. The others who are not so good, I can have a different strategy for them. Then I'll tell them that I have 15% discount for you, right? Now, I'm sure all of you have seen, or all of you even encountered this, right? When you go to these shopping malls and all, right, you will register with your phone number and then they'll send you an offer that Wednesday 7 to 8 p.m. is happy hours. You come and get 1 kg sugar free or some stuff like that. I sometimes see this, right? Now, actually, that's not their happy hour. That's their sad hour. They're not getting enough customers. Okay. So they want you to come buy something, fill that hour, they're doing this hourly analysis using their say amount spent kind of a variable, and they're seeing that this, when they add time to it, you will get that, right? And they'll see that these slots are bad, where people with even the higher income, the best sort of people, are not coming at all. And if effectively to increase their nominal income, to lure them into it, I'll have to give discounts, I'll have to give offers, right, or promotions, whatever. So that is how strategies they'll build and all that stuff. But the point, coming back to this, is that generally I will try to improve my control on certain variables, effectively monetary most of the time. Uh, and they are my target, because if I'm predicting for something, I'm predicting for the betterment of business. As I said yesterday, either to reduce cost or to increase revenue, right? In this case, it's increased revenue anyway. So one of the two will always be the case, right? For that, I will always be having my target variable, which is having some control, maybe minimal control, but I want to increase it. Okay. But the others, which are 0 control, 100 control, there is no point. Absolutely no point in predicting them, because they are not my concern. I hope this makes sense to everyone.
Yes.
Yes. So this is, I thought I always tell this in any session, even before starting regression and all, if I do, because I think this is very important. And when real-time data comes in a program, nice data sets will be given, nice outputs will be coming most of the time. So you will not face all these conundrums, right? But when you go to jump into the real world model building, this is the first question you face. And I've seen people sort of who know a lot of things, have done very well. They are very strong in their statistics and machine learning and all that. But all that comes later. You have to first understand what you want to do, right? Or what is your target, or how you are kind of setting up the thing, setting up the entire spectrum of your equation, right? For that, this I think is generally very critical, the thought process involved in this. Okay. Okay.
I have one question
So
here.
Mayuk, one question. So,
Yeah.
so statistics we are using for prediction. We can use for estimation also. We can use for prediction also. So now, whether this statistical approach can be qualified in terms of artificial intelligence, or it is only a prediction or estimation. Because see, I had a lot of debate with some of my professors regarding
Yeah.
this. So whether only machine learning or will come under artificial intelligence if I do on top of that, or only if I using a certain model or framework, like statistical framework for prediction, estimation, or maybe like filters. There are many filters which we use for prediction and estimates, like Kalman filter and all. So whether they go under the category of artificial intelligence.
Yeah, I think it's a borderline question, to be honest, Tarun. See, if you ask me, linear regression, logistic regression, the statistical models, right? They are not really a lot of artificial intelligence is involved in that, to be very honest or fair. Okay. The way we define AI today, right? It has not a lot to do there. The moment we go into tree models and neural networks, we embark into the AI slowly. Okay. But given that they all come into the umbrella, and the moment we are saying that we are training models and we are testing it against validation data, right? That is now encompassed under the entire AI umbrella. But if you want to break it into really whether I'm using machines intelligence or artificial intelligence in these models, the answer I think is no. It is more statistical than what is driven by artificial intelligence.
If you use the data which is predicted by these filters, and then use those data for training the model, then it can qualify.
It can, and then there comes another debate, which is a little out of scope, but I'll just spend a few seconds on this. Then say, for example, I'm building using these filters for a statistical model, or using these things for any estimation purpose, right? And then I'm using it for a neural network, for example, which we often do, right? Or which we do for a core AI model, right? And that sometimes, as you said, is correct. The transition happens properly, and I can say that it qualifies as a artificial intelligence model. But I have to be very careful that I am not imparting a lot of statistical insight into a core mathematical model. That boundary is sometimes very difficult to understand where it is, and we often overstep. Okay, I don't know whether I'm able to explain it properly here, but that is a boundary. When we do models, it's more evident. When we go into, say, boosting models or neural network models, it's probably better explained there. But that can be a problem. And I personally, if you ask me, I have a lot of reservations about that. Using statistical outputs for tree and neural network models, and vice versa. using tree outputs for statistical models in terms of say EDA to a model transition. Okay, because I have seen that we generally tend to overlook a lot of one aspect by just kind of transitioning it to the other. Okay, so these are vague areas, to be honest. I mean, you can explain it in many ways, but at the end it still remains a vague area.
Yeah, okay, got it.
Yeah, okay. All right, so I'll stop this part because this sharing, what my aim was, sort of done. Okay, now what I'll do is that, as I said, oh, it's already 10:50 anyway. So what I'll do is that we'll get into a quick, I'll show you some slides. No, before that, maybe I'll show you the coding. Let me go to the step-by-step coding first. Obviously, these codes are written, outputs are given, but that's not the reason I'm showing it to you. I'm showing it to you more from a sequence understanding. Okay. Okay. Okay, so this is a manufacturing real-time data taken from sensor and manual logs. Okay, so I'll not go too much into it. It's a industry data taken from a plant, predicting oxygen or flue gas and exit of a boiler. You don't need to really know all that right now, but it's more about the EDA part we'll do. Model, though, obviously is not required right now. Okay, we are not going to get into any of this, not required. We'll talk more about this sequence. Okay, now, okay, these are the variables I think I had here or something. Yeah, anyway, so these I'm sure you know. Acha, okay, you haven't done models. Okay, sorry, that question doesn't come right now. This is the data. This I think 1,91,000. All right. So generally, how we start off, obviously, I'm sure this all of you know, is that once we get the data in, we look at the shapes and dimensions, and to get a sense of the moment we run info, we already know missing values, right? Where it is and to what extent it is, right? So once we do that, the first important thing I always prefer doing is to run the describe function, because this output tells me a lot, as we were discussing in the Excel yesterday, the same output in Excel form, right? So I think this tells a lot. You can get a lot of information, especially for your numeric variables from this. And what I do is that I do this kind of a thing. I look at describe and I jot down every single point and a summary of it. So a lot of documentation from that itself, even without doing anything else actually. Because this documentation, I have written it here. I sometimes write it in with a pen and paper, right? And keep it handy beside me. This I do as detailed as possible for all the variables where I need to, because this will always I'll try to reconfirm some of these results using some of the later diagrams and processes, right? So that is a good practice, I think. From this, try to extract as much as possible, as much meaningful outcome as possible. Okay. Then here I have not drawn a lot of diagrams, I believe, but I'm going directly to the missing values because there are plenty of missing values. So 19,000 for everyone, or 10% and all that. This I'm sure, again, some of you will be probably knowing, maybe discussed already. You can draw a missing value heat map, right? Have anyone tried this before? No? Okay. So this heat map is basically, I'm trying to simple with the missing values. I'm drawing a heat map, nothing else really, just SNS.heatmap from Seaborn. Why this might be sometimes helpful is that if you see these white blocks, these are my missing values where they are, right? But in some variables, if I see a continuous white block, right, or a particular area where it is completely missing in a large data, it's not possible for you to filter every single segment, right? So this tells you whether the missing is at random or not at random. Okay, so whether there is a block of missing, whether there is a pattern to be found inside the missing distribution, for example. Okay, so that sometimes we can try to get a bit of clarity by drawing the heat map on the missing. Here it is not really evident. I don't see a lot of big blocks. There may be one here for the time variable. So for a particular, the time is not even given because this is all sensor data, right? Might not have been captured. But anyway, this we look for only for the blocks, the white or the whatever color it comes. It's here I've given a C map, so it's coming as color, but otherwise it's a white block, which is telling me that there is a section where it is continuously missing. Because if I look at this, it's a total missing, right? I only look at the percentage here. But is that appearing where? is it appearing in a equidistant kind of range, or is it at a block at a particular area, right? That is very important to understand what will be my process for imputation. If it is equidistant, a lot of imputation techniques open up. If it is at a particular area, I might have to take a cluster out. I might have to do some hypothesis testing and estimations for that particular area with other variables. So other theories come up. So the process of imputation might be very different in terms of how I see the missings distributed across the entire data. Okay, so that's why this can be sometimes very useful.
So here you have done this heat map against IDs for variables.
Sorry.
So on y-axis, these are IDs.
These are my rows, basically. Yeah.
Okay.
And these are my variables. Yeah. So basically, in a column wise, from the entire row, I think up to 1 lakh, whatever, 99,000 or whatever I had, right? Yeah. So this correspondingly in this zone, there is a missing and all that. Now, that's why this can be sometimes important, because I need to know how the missing in a big data, in a data of lakhs. This, I mean, if you have 1,000, not required really, but if you have a data of lakhs and millions and all, then this can be a very useful way to understand missing values better. Okay. You can do this missing go and all that. That can be sometimes required, but I'll not get into it right now. Now, for outliers, generally, this anyway you will do. Even if not for outliers, you will do this histogram or univariate distributions for your data, right? For your X variables. And you see, this can actually, even if you don't do, you can add a skewness code here and do it, get the skewness. But even if you look at the diagrams only, you don't need skewness really. You know that who are normal, who are not normal, right? Effectively. If you want to drive it a little further, you can get the skewness values and all that. So why am I saying understanding the normality from the univariate distribution is important for outliers? Is that will tell me the outlier process. If I can say that some of the variables are distributed normally, right? Then that opens up the avenue for using the mean plus minus 3 sigma, or that Chebyshev's inequality thing to find out the outliers, right? But generally what happens, unfortunately, most of them are not normal.
Mayur, please repeat which inequality.
It's called Chebyshev's inequality. You know that thing now for normal distribution, that 99.73% of observations will lie between mean plus minus 3 SD, right?
That I know, but this inequality name I have not heard. Yeah.
Okay. It's done. It's proposed by someone called Chebyshev.
Okay.
Yeah. So in statistics, you will find every single thing attributed to one or two names. Okay. So yeah, it's some proposals and their names are there always. So this is important to understand from a normality or non-normality perspective. Okay. Now, if it is non-normal, as we discussed yesterday, we'll have to do then the IQRs and box plots, and then maybe the percentiles to dig deeper and find out the jumps. All that we discussed comes through after this step, basically. Okay. I'm dropping my target, of course. Yeah, target is pretty good. Oxygen here, I think auto category is my target. Anyway, that's not important right now for you to understand this data. I'm just showing the flow of the techniques. I got plenty of diagrams of every single box plot. Okay. Anyway, so this is every single box plot done for all the variables, which is a long thing. And again, a lot of insights, how every box plot is mapping up, showing up in terms of distribution, in terms of cohesiveness and all that. And this particular insights I'm getting, it might be required to confirm or argue against my describe output, which I took before. The insights I wrote down after the dot describe thing, right? So this and that should match as much as possible, or I should get consolidated outputs from using both, right? That is important. Then again, the treatment is not critical here. Yeah, I've done a median treatment anyway, which is an easy treatment to do. Now, obviously, I'm sure all of you understand why median is better than mean, right?
Outliers.
Yes, in any case, see, if I try to kind of simplify things a little more, think of it this way. Distributions can be two types. One is symmetric, one is asymmetric, right? If it is symmetric, mean and median are very close. Yeah, there should not be too much of a deviation between them. If it is asymmetric, median obviously is better, right? If I club the two condition, median works every time. As simple as that. So I generally go for median.
Yeah, generally they say that if there is not much difference mean and median, use mean because it's more accurate. But if there is a difference, then use median.
Yeah, I mean, again, see the difference in which perspective. If the difference is due to my skewness or extreme values, then mean is not useful also, right? If it is normal, yes, then you can say that I can use mean median either way. If you want to check, I mean, if you'll anyway check that, so that's fine, I guess. But other than that, if you don't want to see anything and do, median is probably safer in that sense. It will not make a massive blunder. Okay, all this is done. Outlier treatments. Again, after that, this is important actually. After you do these treatments of missing values outlier, you have to again run the describe, which a lot of people miss. You have to again see the difference with the initial describe, how much movement you are making. Now, one of the things which again, a lot of people, sometimes we all kind of, yeah, get a little, I would say, yeah, unsure of, is that after this missing value or outlier treatments, when we draw this or when we do this describe function, right? At that point, if there is significant amount of missing values outliers, we do expect some changes, right? We do expect some changes in the distributions. Now, then the point that comes in often in discussion is that what amount of change is fine, or what change is okay for this process of missing value imputation I have done or outlier imputation I've done to be passed, or what alarming distribution changes might be forcing me to do a different type of imputation, right? So that's a big question that often comes in, that to kind of validate the process I've taken, the method I've taken. Now, one of the things, again, this can be open to argument, and this is not necessarily a closed kind of answer. Uh, One of the arguments is that if the distribution change is minimal, maybe less than 5% in terms of the values, right? Then whatever you have done is probably pretty okay, pretty correct. But if it is more than that, then the problem comes in. And then one of the things that makes the difference is the change is happening in which direction. What I mean by that is the earlier describe to the second describe after my imputations, if I see more than 5% or 10% deviation in certain variables, I have to also understand the deviation is in which direction. Is it towards normality or is it towards more skewness? That is critical. If it is towards normality, a little more change, 8-10%, maybe fine. But if it is towards more skewness, then we have to stop. We have to find another way of imputation. Am I making sense?
Yeah.
Yep.
Yeah.
So this is critical. This assessment or this judgment is very important, which we sometimes miss in the process of running through the sequence, right? Because otherwise, when you go and show it to your, I mean, show the model towards the end for its kind of approval, if you are showing it to business people who have no idea, you can tell whatever you want, really, to be honest. But these days, and ideally it should be that people will have idea, okay, and they should have idea, right? And these days, again, just to digress for a couple of seconds, the leadership also has to learn a lot of AI. Otherwise, companies will not stand. If they think that we will just dictate business and people under me will do all the AI job, it will not work. As simple as that. Okay. So AI understanding and AI knowledge for leadership is actually more important now, because the decisions are being done by them. And if they don't get, then that's a disadvantage for the other set of people. They will say either they'll be frustrated by not being able to explain what they want to explain, with the other party is not getting it, as simple as that. And or they'll be taking advantage of the situation and making a mess out of it. Okay, which is very common in many companies. Okay, I can name a few, but I will not name them. Anyway, uh, so these kind of things are very important, that this you do. Otherwise, how will you convince? When you are saying that I've done this EDA and this is the data after that, I have changed or manipulated the data to this extent, what is the defense you have in saying that, right? For that, this is critical. Yeah, Venkat, you want to say something?
Yeah, so we are replacing the missing values with the median right here.
In this case, yes. Yeah, that's a case by case thing.
Okay, so if we usually replace by median, then it wouldn't go away from the
Yeah.
normality.
Yeah, in median, that's why we choose the median often, right? Because the impact is generally a little less.
Okay.
But
But other
again,
cases may be leading to
yeah. Again, see, median is only possible when your missing value percentage is what, 5 to 10%, right? If your missing value percentage is 20, 30, then you have to do other things, interpolation, other machine learning models and all that, right? So for those kind of things, you will see changes. And that's why I'm saying that to what extent the change and in what direction the change, that is more important actually.
Okay, and one more thing is,
Yeah.
was also the outlier imputation done here or only the missing value?
I think outlier also, I have hashed it out. I think it was done actually. Then I later on put it up. Yeah, it was done.
And what was used for that? For
Yes,
outliers.
straightforward IQR. That's it. This is
I
the
mean,
code.
by capping or
This is the code. OS2 IQR and IQR. No, this is left out. There was a
okay.
little small percentage is left out, but you can cap it also. Ideally, you should cap it. Yeah. I didn't have time. I had to show this to their group of teams in 3 days. So I didn't have a chance to experiment a lot really for this data. So they wanted some, because they had a urgent board meeting and all that. So they wanted some results quickly. So I kind of left it out and took the easy route in, but that might not be the right route every time.
Yeah, I am seeing few variables here. Like, could you go a little down?
Down.
Yeah, this much only.
This one, right?
So,
Okay.
like here, if you see like steam to fuel ratio and gas CV, this kind of variable, if you see from 75% to maximum, there is a huge shift.
Yeah, I think, yeah, then I think I didn't run this code maybe once I get this output, probably. That is also a possibility. This was code was written, but when I again showed it to someone, I guess I kind of put this, commented it out and didn't go through it. You are right, because this seems that there is still some outliers, right?
Yeah.
Especially for the fuel ratio part.
Right.
Yeah,
And
you're right.
that AH inlet FGS oxygen content as well.
Yeah, that is my target. I didn't change. That's why. That is actually my target variable here.
Okay. Yeah.
So there I cannot do a lot, but I think this one definitely, yeah, there is an outlier. So we haven't done a lot. Yeah. But ideally, outlier is capping off. What we discussed yesterday, right? That process of capping off, that is the important one. Generally, we do that rather than deleting or imputing with anything else.
Hey, hi, Mayuk. One
Yeah.
clarification from my end. So you're telling about that using of median, right? When we have outliers. So then in such
No,
cases,
not outliers. I'm saying missing values.
Oh, okay.
Missing values, I was saying median is usually better than mean.
Yeah. So even if it's a not normally distributed, then we can't go with mean, right? So we should go with median.
Non-normally distributed, you were saying, right?
Yeah, not normally distributed.
Definitely median, yes, no mean.
Yeah. So in that case, what will be the significance of standard deviation? And even when we do for normalization, we can't use any C-score, right? So how do we approach in such case? We have to go for min max.
If you see, you can still use the Z-score. It's not that you can't, but I know why you're saying it, because it's not normal. How will I make standard normal, right?
Yeah.
So I know your reasoning. Do you know central limit theorem?
Yes.
So what does central limit theorem tell? Central limit theorem tells you that when I have enough samples, right? If I take enough samples of decent size, more than 30, especially largish samples, then over a time, my sample means will be forming a normal distribution, right?
Yeah.
If my data set has decent number of points, which will always be the case, right? It will always have hundreds and thousands of points, right? Then when I'm doing it for the model purpose, right? Everything I'm doing for the model purpose in the end, right? So I assume that this will, in the long run, will always follow a normal distribution.
Okay.
That is the reason why we can use a t-test for linear regression. When you do linear regression later on in your program, right, you will see that a t-test is used for linear regression and a z-test is used for logistic regression. When you reach there, please try to understand this or ask when it is being taught that why it is t in linear and why it is z in logistic. It's a classic interview question, which very few people answer properly. And that actually has a connection to your question you asked now. It all depends on the CLT and the approximation of distributions. If you know PMF PDF, I can go to the statistics and spend the next 2 hours, but I'll only take 2 minutes. If you go to the PMF and PDF, you know PMF PDF, everyone?
Probability, mass, and density.
Mass and density, right? Mass and density function, right? So there is a empirical rule that tells a binomial distribution or a mass function, essentially binomial Poisson, negative binomial, whatever it is. They will always tend to follow a continuous PDF, which is normal, or any format of normal, if the number of observations is more than 200. Okay. So that is also kind of follows in the same route as your CLT. And that is why when you build larger models, right, you can use all this, you can have this flexibility in terms of using statistics a little more than you have, say, on a small data in your theoretical way of doing it.
Is it 200 or it is NP and NQ greater than 5, where P is probability? and n is the samples.
Yeah, that is there, but that I think is not the criteria for understanding continuity. No,
Okay.
no.
And what is Z and T? Can you tell, like in one line? I'm kind of
Z and T are two tests basically. Testing
sorry,
in,
difference between for logistic and linear, like
okay.
quickly
So
why we
one line. Okay. See, in linear, the distribution is unknown. In logistic, the distribution, because it's categorical, it is 0, 1, right? My target. So that's why it is a binomial distribution. And as I know that if I have enough data, binomial tends to normal. So that's why I can use a Z there, which I cannot do in linear.
But okay, sorry, I don't want to go into the rabbit hole, but Z and T totally depend on the dependent variable distribution, right? Like X
Yes.
variable.
Yes,
And it has
yes.
something to do with that standard deviation is not known or sample size is greater than 30 or not.
Yes, it is
That
more
is
about the standard deviation is known or not known.
Yeah, because in my experience, I didn't see that Z and T using differently in linear and logistic. Like I think we generally use T test, which gives
No, if you go to logistic regression using even in Python, if you go right, use the stats model, it will give you the Waltz Z test as your score.
it's good to know. Thanks.
Yeah. Because if you only use sklearn as your package, right, scikit-learn, you will not see all this statistical output. Okay. And that is why when I generally prefer or I tell people that when you are building statistical models, always use stats model API. Don't use sklearn. Because sklearn doesn't give you.
sklearn doesn't even have that stats model,
No,
I think, which
no.
all these p values which gives, right? Yeah.
Exactly. Yeah, exactly the reason. Yeah. Okay. Venkat, Arindam, I can see some of your hands raised, but Acha, tell me if you have anything in connection to this right away.
Hey, hi, Mohit, Arindam here.
Yeah.
So
Yeah.
like you explained that data to reduce data sparseness, we are imputing data. But I have question regarding some product analytics. Suppose some new product is being like introduced in our product line. So in that scenario, questions comes up like, obviously when you don't have data, we will be depending on the synthetic data. Right. But at that time, we have decided these are the imputation technique. This will minimize the skewness. But when we launch the product, new data will be coming up, and it's a iterative process, right? Then the data skewness and parseness is getting changed. So how to minimize this iteration, and what is the strategy to decide? I mean, tell the team that you will be going with this kind of forward.
Yeah, you have to provision a little bit. See, this new products and all this actually takes me back to the initial question we started off with today, right? That when to do the splitting of data, for example, right? Because I would ideally, if I see that new products come up or if my data keeps on changing in the production, right? That's what I think you are alluding to, no?
Yes.
Yeah. If the data keeps on changing in the production, then I have to do a lot of provisioning here. I'll give you a very quick example. Okay. It entails dummy variable creation, but I have to go to that. I mean, encoding. Okay. Which in simple terms, even if you don't know now, it is basically converting a string data or a object to a numeric data, right? Giving it 0, 1 kind of a number to make it available for the equation, right? Now, in that case, what sometimes we do is that we create sometimes an additional dummy. If I have say gender as a variable, which is male and female, okay. Now what happens if I say male will be given 0 and female will be given 1? I can say that, right? To bring it back in the equation in simple sense, right? Now, one thing, if I say gender, obviously I don't expect a third or fourth gender coming up in my data. But say, for example, I take city. I take the 4 metros of India, Bombay, Delhi, Calcutta, Chennai, for example. Okay. Now I understand that maybe given how things are, even if it is for IT or for traffic, Bangalore might come up very soon, right? So given that, say in my new data, I have Bangalore, Hyderabad, Pune, I expect a few more cities, but not in my train data. Right now, what I have for the original historical data, I don't have it. So what I can do sometimes is that we provisionally create an unknown dummy, which is not part of my test at this point. So I will not have a coefficient, I will not have a result for that, but I am provisioning it. So if I have a few rows that are coming in my new cities in the production with the new data, they are automatically allotted to that. I'll automate that step for a few rows. I'll give a criteria that not more than 100 rows or something like that. Okay. The reason I'm telling is exactly the reason why I think you asked the question also, is I don't want to bring back or fine tune my model for the minor changes. I want to provision for the minor changes. So I will create an unknown category. So I'll create a slightly more flexible range in terms of my estimation values for the coefficients, for example. So those kind of things I'll do because I don't want to do it every 7 days. That's not my job. So then I'll only do one model all through the year, and my company will say, okay, thank you, Tata, bye bye. Okay. So that I don't want to do, right? So I would like to provision for the small changes so that I don't have to fine tune my model. And that's an art that comes with experience of model building. But I just gave you one example in the dummy variables, how we sometimes I have done and I've seen people do. But there are other ways to do it for the even to accommodate for your outliers and missing values as well. So I will only bring it back, fine tune, and I'll change my calculations or my concepts or ideas if the change in terms of variable as well as the data constituency is quite a bit. It's significant. I hope
So,
that kind of gives you an idea.
yeah, that means we have to be ready with the imputation and strategy, not techniques, because
yes,
by
absolutely.
time changes, the data can be different, right?
Can
Pattern
be,
can
and
be
it
different.
will be, not can be, it will be. It will be, but how much I have prepared my model, which I put up in deployment for the minimal shocks. That is very important. Major shocks, so I can't prepare, as simple as that, right? But for the minimal shocks, can I prepare? Or can I beforehand sort of put them in a way where the small changes in terms of rows or columns or categories are kind of accounted for automatically? I can provision that. So these are arts. Otherwise, what happens is that you cannot go to your internal stakeholders, say your marketing team or your sales team who has given you the project, right? You have pitched for the project and said, yeah, give it to me. I'll give you more lead score than what you are getting right now. Give this data to me. I'll do wonders. And then after 7 days, you are saying, sorry, hang on. I cannot do wonders. I'll have to do the model again. So that is a phase loss, right? You cannot do that. So for that reason, small shocks, at least for a few weeks, months, you have to kind of provision when you are bypassing the model for the final stage.
I mean, this is very much required for feature selection, not
Yes,
in terms of data. I'm
yes,
telling
100% for the features, more for the features. It's more column driven than row driven.
I'm not saying at par for this data. I'm saying features for a product. So the feature will be
Acha, that
decided.
way you are saying. Yes, absolutely. Yes, because that will change faster, right?
Yeah, that's what.
That will change
Yeah,
faster.
understood. Understood. Yeah, thank you.
Okay, once we do all this, generally we also look at the correlation, but this is a optional thing. You can do actually this before also if you want. Why? Because if I have too many variables to do my missing values and outliers, as I think someone pointed out yesterday also, we can do the correlation before. You see something is absolutely unnecessary, I leave it out. I don't take the ordeal of doing the missing value imputation for variables not required, right? So a basic understanding of correlation in the beginning can sometimes, if I have too many variables, can sometimes be a good thing to do so that it kind of automatically removes a bit and I'm left with more meaningful and shorter EDA. Again, yeah, this is very detailed because I had to kind of educate a lot of people on the results, so it's very detailed. Yeah, plenty of stuff written. Don't have to go through all this. But that is how it should be actually. If you are giving it to someone, if you're giving or telling someone, then it should be very, very well documented. Otherwise, you have just written codes and output that I don't think is, I mean, that's not very user friendly, right?
So Mayuk, yesterday you have pointed out regarding the outliers based on bivariate or multivariate outliers, right? So now I am feeling that looking at each independent, like each variable separately, will become redundant, right? Because that actually may be result of some other variables increase.
Yes, I know why you're saying this. Yes, bivariate outliers will do the job, but see again, this variable is this output of correlation and heat map outputs, right, is very important because that will actually curtail a lot of your univariate outlier analysis, right? You will not need to do all 50 or 49, which we were saying essentially, which is, yeah, if you do this, you will expect or you will hope that that 50 can be brought down to 30 or something, right? So you don't need to do individual outliers as extensively as you want to or as you think you should be in the beginning, right? So that, yes, that you are right in a way that you will actually, your emphasis on univariate will go down as you do more of this.
Yeah, so one of the things that I read recently is that tree-based outlier detection would be a
Isolation
better thing.
forest.
Yeah, because isolation forest, it will straight away separate it in the first branches.
Yeah, it will do, but Again, that whole question, which I think I was answering to Tarun's question before, the whole idea of whether I would want to take a tree-based EDA for a statistical model or not comes in. So that is something we have to be careful. Okay, and that is where the boundaries are very thin. We are generally treading on a thin line if we do that. I don't know how much I am able to make you understand of what I'm saying right now. But there is a quite a different shift, I would say, or a quite a significant shift from a tree-based to a statistical or vice versa model movement, right? So I am generally very cautious when I'm taking EDA from one of them and using it as a input for the other one. Okay. So that area remains, that gray area remains, but otherwise, yes, isolation forest can be a good indicator to at least sort out initially. Yes. Okay, so that's what it is, basically the flow. Then after this, here I haven't done any dummies because I didn't have a lot, I guess. But then after this, you have to do dummies scaling and dummies splitting and scaling. That's it. That should be generally the structure or the flow of the EDA. In other special cases, you might have to do more feature engineering, more other things and all that. But generally, these are what should do the job. This sequence of doing it. Sometimes we also do multicollinearity, other post-model things in the pre-model scenario if you have too many variables, or maybe other dimension reduction techniques like I think some of you are saying PCAs and factor analysis, those kind of stuff. But that is case to case. But this what I was showing and we were discussing is generally the case every time. It's more generic. If you want to, I mean, you have to add or superimpose things little more on this. That is case to case.
And
I would say.
We don't need to do the dimension reduction in every algorithm, right?
No. See, dimension reduction, let me tell you a very easy way to understand how this can be a problem sometimes. If I plot my number of rows and number of columns in the x-axis and y-axis, okay, we know how to plot a scatter plot in x and y, right? If I have a two-dimensional plot, in one of the dimension, I say I will take the rows, number of rows and the rows, and in the other I'll take the columns. Okay. Now, where the dimension is the problem? Let's think of it this way. Okay. Dimension is a problem when I have too many rows and too few columns, and I have too few rows and too many columns. And in another separate case, when I have excessively high number of columns only, right? These are the three scenarios where it is a problem.
Too few rows and too many columns shouldn't be the problem, right? Because
it is a problem. It is a problem because then what happens that your columns are overlapping in terms of impacting every row.
Overlapping.
If I have, say, for example, if I have 100 columns and 500 rows, right, in a data, it is going to be a problem because what happens is that if my 100 columns, if I take, then what happens because only 500 are there, I will not get enough variation within the columns to explain all the rows.
So it is too many columns and too few rows.
Exactly. Yes.
I'm saying too many rows and too few columns.
That is also a problem.
Why?
If I have 5 columns and 5 million rows, I will not fit a model which is sustainable. It will always overfit.
Always overfit.
It will always overfit, even underfit also. Forget overfit to hoga hi, but underfit also. It will not give you the good outcome in the first stage itself because you have no leeway to remove any variables, right?
So when you add more data, the row you decrease the overfitting actually, and when you increase the column, you increase the overfitting.
Yes, but that is when I have a stable set of columns. That is when I don't have very few columns. If I have too few columns, like 5-10 columns, right, and I have a lot of rows, 1 million, 2 million rows, right, then the problem can be that I will not be in a position to remove any rows because across all these 1 million or 2 million columns, right, some of these rows, some of these columns or some of these variables, there is a high chance that they will be redundant, be it for overlapping multicollinearity, be it for insignificant statistically, right?
But that is the problem of the data collection, right? Sampling. It's not the...
Absolutely. No, it's not your problem, I'm saying, but you will get a result which is bad, right?
I have to check on this, but yeah.
Yeah, you have to get a bad result. Yeah, I know that the problem is not with the data science team or data analyst person. The problem is more quality collection wise problem, but it will still be an issue when you are getting the results.
Because in my understanding...
Let's say if or those 5 columns only are able to explain your entire data and the independent
It is still sometimes a less desirable output, even if it does, which is rare, but even if it does, it is still sometimes less desirable, because in production, every single time you will get 1 or 2 columns coming in every 7 days.
In my understanding, more data has never been the problem. It is more columns which are the problem.
Always, yes. Generally, the more columns is always the problem. More rows, the better it is actually,
The
as
better it
long
is.
as
That's
you
why
have decent number of columns. That's what
Yeah.
I'm saying. Yeah. So more rows is never a problem, because your tool will do the job. You don't have to go through the rows, right?
Yeah.
But more columns, you have to do the job.
Yeah.
So that is more for dimension and all that. Share the code file. Yes, that can be shared. Data, I'm not sure I can share. This is yeah, this is a pretty confidential data. Okay, I can share the code file.
Mayuk, one question.
Yeah.
So when we see high correlation between two columns, do we remove one of them?
No, not that way. We have to check for multicollinearity using a technique called VIF.
Okay.
That way we can do. But sometimes what happens, if we see the correlation of a particular variable very small on my target variable, right? Then we can remove it in the beginning. And using the, also we have to check with the business as well, that is this relevant for you or not. Sometimes not only statistically, we have to get a vet from the business as well.
Okay.
But otherwise, in a modeling sense, no, that is not enough. We have to look at VIF for that.
Okay.
Okay. Yeah, so this is the more or less the flow I wanted to show you. Generally, yeah, it will hold true, but again, don't kind of take it as a rule or a gospel in any sense. Nothing is rule here. That's the beauty or the danger of data modeling. Okay, that's where the trickiness and the interest both lies, right? Nothing is fixed here. There is no rule. It's like, I remember when I went, I tried to appear for IES exam long back. I had economics, so I tried to, and I asked very innocently someone that what is the syllabus, and that person laughed on me and says, yeah, you are coming for IES and you're asking for syllabus. So data science is a bit like that, right? You don't have a set things or rules or syllabus for that matter. Okay. All right, I'll go quickly. Oh, it's 11:25. Okay, I'll go quickly and show you a couple of short PPTs which I have to show, which I want to show. Okay, let me share this screen. Yeah. Okay, so let me put it in reading mode, maybe. Yeah. So what we are doing here is, okay, I'll put it back to this mode and then start from here. So I'm saying it's more about outliers and missing values. The EDA part, the main EDA part, which we discussed so far, it is more about some domains I've taken: manufacturing, pharma, retail, and banking. Okay, there is obviously more, telecom and all, which I couldn't incorporate in this, but it will kind of cover most of it anyway. This is for manufacturing. Again, I don't know any of you are in manufacturing or not, but I guess given there are a lot of people, I am sure some of you are. This is again a guideline. It's not that every time it will hold true or anything. Nothing is every time in this field. Okay. So we have generally sensor data, we have manual logs, we have time series data, we have edge cases. I'll come to edge cases if you don't know. And root cause analysis. Again, I'm sure you know what is root cause analysis and how we do it. It's more manual work, right? If it is sensor data, right, which is more kind of automated in that sense, what we generally want to do is we say that if to find the continuity, it's a bit like stock market data. We do the backward and forward fill. Everyone knows backward fill, forward fill. Very easy, the easiest thing to do. Take the previous and take the next or the next value to fill up your missing values, right? You can take the backward forward fill, or you can use a linear interpolation, which is basically take the two data points between which the missing value is, draw a line between them, draw Euclidean distance, get the middle point in the coordinates, and use that value as your imputation. That's a linear interpolation, right? Or you can, for the manual logs, what we generally do, this is again more from my experience, and I have also referred a few documents for this. Manual logs is using basic stuff, because manual logs, you don't want to get into too much of interpolation and all that, because you are generally the percentage is less and you can do a median. Okay. Predictive modeling for time series data, again, this might be a little out of scope, but I just want to give you the full spectrum. So I've written it. There is a model called ARIMA model. Anyone who did forecasting will know this, autoregressive integrated moving average model. So that is, or LSTM is the long short-term memory, the sequential neural network, which can be used for to fill in the graphs, basically modeling to impute missing values. Edge cases, basically, we call what as edge cases is basically where the missing values are my borderline data. Okay, where they are essentially my borderline extreme or outlier data. So the outlier and missing value kind of overlap a little bit in the edge cases. Okay, so here we have to be a little careful. We sometimes treat them together, missing value outlier, club them and do one treatment if we are very sure of it, or sometimes we just flag it and create a different category out of it. Again, depends on the scenarios. Root cause, obviously you have to investigate deeper. There is no method for that. Okay. Outlier, Z-score IQR is generally the process, right? For real-time anomaly detection, we sometimes in manufacturing, at least what we do is that we use the control charts. Okay, control charts is basically a simple single kind of line diagram where with respect to time, you see that where the outliers or the changes or the ups and downs are happening. And accordingly, you flag them. So control charts can be a good way to detect outliers in your in manufacturing data sometimes. Domain knowledge is super critical in manufacturing because whatever I have seen, be it in the power industry, aluminum industry, wherever I have worked, the data I was showing is also for a power data, right? In those cases, this domain knowledge is important, but it also it has its pros and cons. I've seen people who are head of the plants, power plants, and all these plants, different plants in the country. And if you go with any data science solution to them, they'll say, "What will this do? I have 25 years of experience. You will know more than me." I've literally heard a lot of people say this. Okay, so yeah, there are challenges, but domain knowledge is still important. Now, and segmentation is more of heterogeneity, which we were discussing yesterday. Okay, if you see a lot of heterogeneity in your data, in terms of in the control chart, perhaps you will see a lot of heterogeneity, right? And then you can analyze or segment the data, use a cluster or something with respect to say machine or shift or operator to isolate the anomalies and build separate treatment or separate models for them. Okay. That is for the manufacturing. Anyone has any question?
Like what is the Z-score IQR? Is it a technique?
No. What we discussed, the usual our thing, no? Z-score IQR. Either Z-score is basically mu plus minus 3 sigma, that thing for a normal distribution, or IQR for a non-normal thing. Usual outlier.
Got it. Yeah, I
That
think
one only, the basic stuff, yeah. Now we go to pharma, which is always the tricky part. Okay, manufacturing is also tricky. Pharma is also tricky. I don't know how much you know about missing values really right now. I don't know whether you know at random, non-random, completely random. There are different ways to classify missing values as well. So in generally, if you see missing at random, what does it mean? Missing at anyone knows what is missing at random?
There is no pattern to the missingness. It's completely
That you are telling from the name, I know. But anything more you know on that?
no, that's it.
Missing
Okay.
from different columns?
No, not really that. So missing at random, the way we generally define it is that it has a the missing values have a very strong relation with the other observed variables, with the values in the other variables, but has a very weak correlation or weak relation with the other missing values in the same columns. So in the column sense, the missing values are at random, but with respect to the values in the other variables, there is a pattern. That's what we call as MAR generally. And usually that is very common in our clinical data. Sometimes it comes, I have very limited exposure to be honest, but I know someone who works extensively in pharma and he was telling me that this is pretty common. Okay.
Could you explain with an example?
So is it every missing value is a special case?
You can say that actually. Every missing value is not related to the other missing values in that same column. Or there is no serial correlation among the missing values, if you put it that way.
So if we do some kind of EDA on the missing values of the missing at random column, then do we find some pattern on the other?
We do. With respect to other variables, especially we do. We should get. you should get. But that is a very deep theory. I will not get into it and confuse you. You are just learning missing values. So at random, there is another thing called MACR. Okay, you can read up later on your time as well, because these things take hours and hours, right? Not 1 hour or 2 hour. So there is a MACR which is missing missing completely at random. MCAR, sorry, missing completely at random, and this is only missing at random. So there are differences, and it uses a bit of probability to do that. Very statistical in nature. But again, very domain driven. If you are working in retail and banking, you will not get a lot of this, to be honest. But in pharma, what happens? No, because some of the data in pharma is data, say, for example, with test results, or say with diagnosis results, right? And that is very dependent on the certain elements of human body or human kind of impact comes in, right? And there it can be these missing values can take very different types of patterns actually.
Could you please explain this MAR with an example, a simple example?
Simple example. Okay. MAR ka example can only take values and do it maybe. Okay. Let me escape and here only I can do it. Not a big deal. I will again have to, if I go to Excel, I have to again go and share different screens and all that. Say, acha, you have an idea of what is serial correlation?
Yeah, serial correlation.
You know, right? So serial correlation doesn't mean correlation between X and Y. It is between the values of X, right? Right. So say I can say that in this case, the serial correlation between the missing values in a particular column, whatever it is, in column X, for example, is close to 0. Okay. But the correlation between these missing values as a group, of course, with the values in neighboring variables is high.
Okay.
This is what we call as MAR in short. Okay. So then the imputation will be very much driven by my other variables rather than my pattern in the same variable, right?
Right.
That is where the why we are kind of classifying into MAR is because we are assessing in a with an angle of what should be my imputation method, right? And my imputation method is not going to be found in the same variable with mean, median, what we do generally, right? It has to be interpolated from other variables. That is what it kind of comes down to. So I'm just used the correlation concept because you already know it to kind of break it down a bit more.
Okay. Yeah.
I think I wrote down in the first slide. Anyway, it doesn't matter. Okay. So there is a process called mice. Okay. Now mice, this is not the mice. It's called multivariate integration, I guess. Imputation. Yeah. Multivariate imputation by chained equation. That's the full form. Okay. Now, this multivariate imputation, obviously you understand that because we're looking at other variables to give us things, right? So then that's why it's called multivariate imputation. You will look at all the neighboring variables and then use them for the imputation by chained equation. What is chained equation here? Is that you will use each of these neighboring variables where the correlation with the missing values of this variable is very high, okay? And you will try to find 3 or 4 different imputations or set of imputations, okay? And then see, after running a describe function, which one of them is having the lowest deviation from the previous describe. And then you will choose that imputation as your best imputation. A lot of work, but in proper research work for data science, that this kind of thing is done actually. Did that kind of make a sense? I know I'm going 1,000-foot overview and all that, obviously for the time and everything. But did that kind of give you some idea?
Yes.
Yes. Okay. Anything you come back to me, you can come back to me if there is anything afterwards you find, or you obviously study a bit of things on the basis of this, because we are just touching on topics, right? We're not necessarily getting into them a lot. So if you get that, obviously you can come back to me after this also. It's not that I'll disappear after 12 p.m. today. So that can be done, of course, all the time. ethical handling is very important in pharma. You should not delete anywhere ethical handling, but more critical here. And regulatory constraints is very important. I know someone who works in some diabetes drug company, okay, in Bangalore, and once they were given there was a hefty fine for not getting their data manipulation done using FDA compliance. Okay, so that is also critical when you are doing in pharma and all that. Winsorization is important, which everywhere in pharma also, because winsorization is nothing but the capping method I told you. Reduce extreme values while keeping them, taking the next highest value. Sometimes we do a transformation, log or box box transformations, and looking for the ranges. See, remember also when we do a blood test, all of us, right? We see the results in ranges. Say your hemoglobin ideal range is what? Say maybe 14 to 16, something like that, right? 12 to 16. So that range is given by empirical statistical tests over years and years and years, right? Now, when we are doing our model, or when we are doing a model which has to comply to this ranges sometimes, right? So then this trials of biological plausibility is very important. That I am looking at my SME or the medical professionals essentially. So I am a data person. I will not know all that, right? So that conversation is very critical. Otherwise, I'll say, no, my model is giving me 11.5. The healthcare person will come back and say, it's not possible. The human body doesn't give that. So that is very critical in pharma outlier, and especially outlier treatment, not so for missing values. This is retail. Customer data, generally, the numbers or the percentage is pretty low in terms of missing. So usual median will work. For transactional data, we can sometimes do something called a collaborative filtering. Okay. Now, collaborative filtering, I don't know any of you know what is collaborative filtering? Have you heard of this before?
No.
Yeah,
No.
it is used
Okay.
for the recommender system, right?
Yes, absolutely. It is used for the recommender system. Right. You are correct. So collaborative filtering is used for recommender systems for identifying the patterns. On those patterns, we can impute our transactional data missing values. And if it is a time series data, then we use time-based interpolation. Okay. So I'm telling you I'm giving you an idea of the things what we do. Delving deeper, obviously, yeah, each of them takes time. Okay. Unknown category, we have discussed this actually, assigning unknown or other for the segmentation. Yesterday, I think we were discussing this.
Mayuk,
Yeah.
I have a question on log and boxcox transformation.
Right.
Why we use it?
Here it is more for a different scenario of outliers, but in general, if you ask transformation and okay, let me ask you one question. Ask you back one question. What is the difference between transformation and scaling?
Transformation and scaling. Good question. Scaling does scale the variables. Transformator is like
Transform the variables.
Looks like the same, but yeah, I don't know.
Yeah, anyone else who wants to?
Yeah, transforming to a data which is used for the algorithm, like.
Okay.
Even
No, I'm not saying from that perspective. I'm saying that from a result perspective, what is the difference?
So scaling does not change the distribution pattern, but
Yes,
transformation does.
that is the point I wanted to hear. That scaling does not change the distribution. Transformation changes the distribution. Okay. So generally, when I am building my models, as you saw, right, you saw the feature scaling, you already know, right, that for our independent variables, we do scale them to bring them at par with each other, right, using the Z or min max, all those scalars, right? So that is scaling. Transformation, which, as I think Rajat was saying correctly itself, that it is a change of distribution. Now, why will I change a distribution? I will change a distribution when I understand that my distribution is very scattered, right? Or generally when the scatteredness is too much. In our models, in our continuous variable models especially, we do transformations for our target, and that is post model. Generally, if our target variable has the actual values are not connecting to the predicted values I am getting from my X data, right? And if the actual and predicted are not connecting properly, then the errors are very high, right? So if the errors are very high, we do this log, boxcox, or even sometimes square root also to bring down the error. Get the model in a different. That is where the general usage of transformation is more there. But the idea comes from the fact that it is changing the distribution and not what scaling does.
Yeah, but if I'm predicting something, why I am changing the data and then predicting it.
Because it is not enabling me to do the statistical prediction. I have to again take it back. If I do a log, I have to do an exponential and show my results to my wherever I'm showing
Do
it.
inverse of that transformation after we make
Absolutely, yes.
Okay.
So
We can see
Boxcox is actually used for like skew data, right? Like
normalized.
when we are
Boxcox is a form. I mean, it's a form of log only, right? It's a extension of that.
yeah. So like when target variable is skewed or something. So at that time.
Yeah, if it is skewed, we use Boxcox. If it is positively skewed, we actually use log. If it is negatively skewed, we use exponential to bring it closer to normality.
I think log doesn't do normal. That's why I'm just kind of curious.
No, it will not do normal, but I'm saying it will push the values closer towards less skewness, right?
Yes.
Bringing the values lower. That's the idea. It will not exactly normal. No, it will never happen.
But you mentioned that scaling doesn't do change the distribution. Isn't min-max scalar change the distribution?
No, it doesn't change. It is just changing the values, but the relation or the ratio among the values still remain the same. It is just bringing down the values, the numerical values for those each of them.
The missing value imputation is just a kind of transformation only, I would say, right?
Yeah, missing value is more transformation because you end up changing the distribution, right?
Right.
So Mayuk, related to this, so we were talking about transformation, and also we have to take the inverse of the transformation before like
Right.
showing our prediction.
Final results, yeah.
So similar to that, like when we do PCA, we can also do inverse of PCA at the end, right? Because we have the linear combination of the.
That's what we do. We try to do that, but that also you see the PCA is built using linear combinations, right?
Yeah.
That the coefficient I'm getting is for one principal component in a model, right?
Yes.
So the coefficient connection to each linear component, if I take them back, is not the same for getting the coefficient for individual each of them, right?
Can you repeat that concept?
I'm saying, say that if I don't do PCA, right? What I do, I get coefficients for each of the variables, right? But if I do PCA, and as you said correctly, that if I do PCA, I can again bring them back in that way and then connect to the coefficients, right?
Yeah.
But do I have so many coefficients? I still have one coefficient for all of them in that PCA, right?
These things actually, you explain it well in the spreadsheet, and I know it's like, time constraint. It's better to show with maybe the code and like, how this is looking, especially PCA, how we back transfer.
PCA, yeah, the eigenvalue back transformation, that part.
Yeah.
The code directly does it. Yeah, PCA is a topic. I think coding is pretty helpful, actually. It gives you the results you want to see, to be honest.
But I thought we cannot go back from PCA to
You
our
can.
actual variable.
No, you can go back in a way that where you go back to your using your matrix, right? You can go back in the matrix sense, but not in a coefficient sense. We cannot do that, right? Because we want to find individual variables contribution in a component, in a principal component, right? But how will I find that even if I take the eigenvalues back?
Okay.
That I will not be able to do.
Okay. So you mean we will go back to the original columns from where everything has happened, but we'll never
We'll not be able to interpret,
Yeah.
That otherwise, I mean, then it doesn't make a lot of difference, right?
The main issue with PC is that interpretability. That's why
that's the problem. Yeah. That's the problem.
I mean, I still don't get it, because if we are still looking at the results in the PCA output, then we can't interpret it. But
No.
if we are able to transform it, like inverse of the transform of the PCA, then we will be able to interpret, right?
But interpret in terms of why, how will you do it? Because if you transform it back, then you get again a lot of variables, all the variables used for the PCA, right?
Yeah, the initial variable.
Initial variables, okay, I get that, fine, I reach that. But for this PC or this principal component, I have only one coefficient from my model, right?
PCA has like, sorry to interrupt. Suppose we have 10 dimensions, it will make it 2 dimension, and all the dimension will have mixture of all
embedded.
That's
Yeah.
why we cannot.
Each PC will have like each PC will have one coefficient for each of the. Like if we add 10 variables, we'll get 10 coefficients for
10
each.
coefficients for each PC will get a coefficient, right? If I run the model with the PCs, right?
Yeah, each suppose we are talking about PC1, we'll and the
get a one
model has
coefficient,
10,
right?
if the model has 10 inputs, then we'll get 10 coefficients, right?
No. Then I have to run at the model level, right? Not PC level.
So let's see, we have top two. Yeah, let's say top two is explaining 90% of variance,
Right,
and take to
right.
top two. In those top two, how can we convert? Because we don't know, there is no one-on-one mapping, because every
That is what I
company.
was saying, that there is no one-on-one mapping. I can convert them back, but can I convert them back to my coefficient? No, right?
So what you convert them actually, if you're not coefficient? What are you talking like?
No. What
when you say
Venkat is
convert?
saying that I think what he's saying is that you can bring it back to the original contribution of which variables, right?
Actually, I'm talking about when we get the output from the predicted model, when we use PCs, then we can map that output into our initial input variables, right? Because we
No.
have all the linear combinations.
Yeah, but again, that's a question, right? How will I map it to all the linear combinations? Yeah, Meghna, you want to say something?
Yeah, Max, I rather wanted to add here, like I think
Yeah.
a basic understanding, PCs are not like a one-to-one mapping to the main data and you map back the main data to PC. So again, like when you even do PC, it's not like the 100% of the data is getting converted to principal components, just like some ratio of the data.
Ratio
So
of it, right?
yeah, so the intent always is to either visualize or your accuracies or I think
It is
I
more
mean,
of an accuracy driven method
yeah.
rather than a driver driven method, right?
Yeah,
Yes, yeah,
now I
that's
get it. Now I get it. Because it is like we are reducing the dimensions, so it's not a one-to-one
Because
mapping.
my aim here is to reduce dimensions, not to get individual coefficients, right?
Yeah.
Okay, so this is yeah. Okay, so I don't know whether you know DB scan clustering yet. You'll probably know at some point, which is used to find outliers for clusters. Okay, and that can be very useful for retail data. DB scan clustering, which is a very popular method these days. Okay, we have k-means clustering, which is the traditional method, but k-means doesn't work well with outliers. So we use DB scan to detect outliers and then sometimes go back to k-means to build the clusters. Okay. Business context is important for retail. A lot of promotions and holidays and yeah, US holidays, Indian holidays, everything comes in. Okay. And automated flagging. We have to do automated flagging for the real-time fraud or the real-time red flags essentially. Okay. That is very important because otherwise I will not have time in the production to bring back all these outliers and do treatment. The damage would be done by then. Okay. So the automated flagging we have to initiate in a large data especially. KNN imputation, again, a model which some of you might know, some of you will know. We can use KNN to build our customer data for banks. And again, I'm sure some of you have worked in banks here. Everywhere there are people who are working in banks. So treat it as a separate category for credit scoring is what usually works well. Okay. And for derived features essentially for your dummies and interaction variables, those kind of derived variables, right? The feature engineered features, basically. You can use flag indicators or you can use indicators that it's a missing 0, not missing 1 kind of a flagging you can do, right? That is generally what we do for banking. Essentially some decision tree or KNN for customer data. And for the rest of it, maybe categorization, which generally works better. Okay. And I think someone was mentioning isolation forest a little while back. So anyway, that is there for fraud detection. One class SVM you can do. If anyone knows SVM, you will know what is one class SVM or a multi-class SVM using kernels. And you can use autoencoders. That's far away. Don't worry about it right now. Autoencoders is before transformers using your RNNs and GRU models. After neural network, obviously it comes. That can be also used to do fraud because fraud is a scenario where you miss one, you make a mess, right? So you cannot wrongly predict any of it. Ideally, you cannot afford to wrongly predict anything, right? So for that, we sometimes use autoencoders to be make things very robust and all that. Okay. And the rest of it, I think, in anomaly scoring and all, I believe is straightforward. You can assign scores rather than binary labels if it's anomaly scoring. Extreme transactions is, yeah. Model as rare events instead of removal because removal is not really a solution in most cases. Okay. So I think this is the end of it. Yeah. Generally, I've put in some things. Yeah. Combine statistical plus business insight, which you know, but you still know that business insight will always take the upper hand and as it should. And domain understanding is critical. And the ethical part, I've kept it because I think that is very important. Your ethical understanding for a particular data, for a particular problem statement you're working is very important. I see people, just to give an example on this, I see people who are essentially, say, part of a consulting and some project or case study is given, right? Or a training, say, for example, and some submissions have happened. What they do, I've seen this happen, is that they'll submit those submissions into Chat GPT and say, give me the results. I mean, that's a horrendous way of using AI. Okay. Your Chat GPT or all these kind of AI assistants are not there for giving you bulk results from data. You are feeding them data, feeding them wrong inputs. So later on, for yourself itself, when you search the same thing, you will get wrong results. Okay. So you're essentially polluting the place and making it less effective by trying to get a shortcut for your short-term result. Okay. So that ethical understanding at an individual level is very important. Just because I have a lot of AI tools at my disposal, that doesn't mean that I will make them work every single time and kind of jeopardize things for others, right? That's not necessarily a very good idea to do. So that has to come. That is a very organization level thing, and that is still evolving, but that is important. Otherwise, we are not going to go too far if the ethical regulations are not in place. So yeah, that is pretty much what I wanted to show from this perspective. There is one other thing I wanted to show, but I don't think we'll have a lot of time for that. I'll not get into that and kind of stretch it beyond a lot of, beyond too much of excessive time. That was more for governance and ethics. We can do it later on if required at some point. Maybe we can catch up and do it. That we can decide and figure out. That would have taken around half an hour or so, 20, 30 minutes at least. 20 minutes minimum, I would say. So I'll not get into that, but maybe we can open up for questions for 10, 15 minutes if that's fine.
Yeah, before we get into the questions, I mean, if we manage to request featurings for your extra such sessions, would we be, available for it?
That
That would be
we'll
lovely.
have to decide. We'll have to decide.
Yeah.
Right now, yeah, maybe depending on how much progress you are making and at what levels we might want the interventions is important also, right? So that you take it offline and we can figure out. Yeah.
Yeah,
That's
yeah.
fine.
I mean, I think I can speak on behalf of the whole group. Like, I think we really liked your teaching, and I think we really would learn benefit from it. Yeah.
The ironical part is that I didn't taught a lot.
Yeah, I mean, still, we grabbed a lot also.
I didn't teach a lot really. I just went through a few things. That's it.
Yeah, but
Anyway,
you have covered like the very foundational things, the interpretations that should be used for the model.
I think that is important, right? Because if you skip that, then you skip the essence of it, right? The main essence of getting into all this, right? So I think that is critical. Yeah. All right. Questions now. Yeah. Go on.
Can you share some statistic books?
Yeah, I think I shared a few names yesterday, but I can do that. Yeah, Meghna, you can start.
Hey, so when you were talking about the test and train data split, right? I have a different idea. Like it's not, I mean, as I know, or I have implemented, it's not always at the beginning of, process. So what happens like when we do our EDA, it's always it's 100% of the data. And when we suppose, say training on say 80 or 70% of the data, right? Then your data or the fit needs to be aligned what you're going to transform on your test data set. Right. And a classic example is, say, time series forecasting when you say calculate your MAP accuracy, whatever metric you want to do. So that splitting comes at the end when you're actually fixating like, okay, your training went well, your data coming right. So that happens at the later end point, right? So it might not be every business scenario or every implementation scenario, it happens at the beginning, right?
No, you are right. And especially the example you took in time series, it has to be at the end.
Yeah, yeah.
Because remember, in time series, the splitting is not the same as, say, a regression. Because in time series, we are not doing a random splitting, right?
True. Yeah.
So time series, we are saying that the last 1 year data or last 10%, 20% of the data is kept as test, right? It's a sequential splitting. In a sequential splitting, it has to happen at the end. But when I'm doing a random split, I might want to do scaling and dummy variables after that.
But again, like it comes after you do your EDA techniques, right? Otherwise,
no. It generally say univariate, bivariate, those distributions you should do before. No doubt. Yes, absolutely. The missing values outliers also you should do before.
Exactly.
And then, yeah, I think the one argument I have heard a lot of people do is that then if I am doing dummy variables after, then why not I will do any outlier treatment after also. But I do agree with you there. I think outlier and missing value should be on the main data. Okay, because in that the constitution for those treatments should be intact as much as possible. But for each feature engineering, which is more of your scaling, interaction, dummies, those kind of things, right? Or creating new features, that can be done afterwards. But not, yeah. Otherwise, yeah. Otherwise, the other thing should be before. It makes more sense. Yeah. Because you don't want the data to be split a lot prematurely and lose your essence of it in the beginning and then try to map and match,
Test will
right?
not sit with the trained
Exactly,
data.
map and match, right? The overfitting will be a little bit beyond the control. You can regularize and all that, but you don't want to just regularize for the sake of your lack of prudence in terms of splitting, right? So that balance has to be there.
But if you
And
use the sorry, go on.
no, it's like a next topic. Venkat, if you have something from here, please go ahead.
Okay. Okay. So my follow-up question is that, but the same as the initial one that I asked, if we are doing missing value imputation before the train test split, that is like incorporating the test data's y value into the data, right?
Come again. What are you saying? Come again.
Like there is a data leakage, right? If you are doing the missing value imputation before the train test split.
No, I don't think there will be a data
Because
leakage for
even the
yeah.
test set that will be formed after the train test split, even that values we are considering to okay, but it is not y value. Okay, that
Yeah, it's not y value. No,
not y value. That is only if the class specific imputation.
Class specific, exactly. Yeah. It will not work. I mean, it will not be any effect for other scenarios, right?
Yeah.
And in test data, I think we can't have the missing values, right? We need to have the all the values. We need to get
that we have to sort beforehand, right?
Yeah, before.
But that not always the case, like in the practical data. Even like the test data
Yeah,
can
I
have
know.
missing values.
I know. That's not always, that is ideal, but never going, I mean, yeah, there is aberration very often.
No, we will split it after our imputation. That's what I'm trying to say. And when the new data will come, it has, I'm not sure. There will be checks that it comes as a, like any record which comes, it comes as a, like no missing value. Yeah, I'm not 100% sure though.
No, I think, see, you will do the imputation beforehand, of course, but when the new data comes in, or even for your validation purpose, right, you are bound to get a lot of missing data sometimes in many industries, right? You will get a lot of missing data. So that you have to put in your system in such a way, in your pipeline, right, that is taken care of. And then you can impute or not impute, you are implement your model on top of that. But missing data will be there. It's not that it will not be there when you are using it for the next time, the same model.
Why we use I mean why support vector machine is good for the banking fraud cases? I mean, can you explain on that?
Because in support vector machine, if you go through the concept of the algorithm, right, in support vector machine we are trying to create a boundary, right? We are trying to create a boundary between our categories, right? And in fraud, what happens is fraud is a categorical data which has a 0 1 thing where the one of the categories is very small, right? It's a imbalanced data, what we call, right? For a imbalanced data, support vector machine can be a better uh, predictor than say your usual decision tree or random forest. That is the only reason that your chance of imputing the frauds as frauds is more because the predictor is better. And I have written support vector machine there. You can actually use the XGBoost for the same reason as well.
Okay.
It's more for the imbalance. It accrues to the imbalance, which is obviously going to be there in fraud. You will not expect a 40-60 or a 50-50 for a fraud data, right?
So it'll always be 0 1 or kind of
it will be 0 1, but one of the categories, your fraud people will be only 1 or 2%, even less than that, right? The non-fraud will be the majority anyway.
Okay.
Yeah.
Can I ask you, yesterday I forgot, sorry, about the books, for stats.
I think someone has put in the chat again, I think.
Oh, is it? Okay.
Yeah, I think Venkat has put it for everyone, I guess, a couple of names. Yeah.
Oh, okay.
Mayuk, I had a follow-up question. I was checking. It's regarding the correlation coefficient. So when you were talking about that heat map, right? So when we do feature engineering and we see like, okay, the coefficient values say 0.98 or 0.99. So usually we consider them as similarity and we remove them for the features that we take for models. Why did you say that we need to analyze further, right? What were those scenarios?
See, there are two ways. I think what I was saying is that sometimes when we do the heat map or the correlation thing, right? When we do that for say before our missing value and outlier imputation. Okay, what I mean by that is that if I have an idea or if I have a sense that I have to remove some variables from my initial EDA also, right? There I would try to understand their correlation or relation with respect to my Y. Okay, and there as you say, I can definitely remove them. I can remove them in the beginning and they say that they have no impact on my Y. Also, if they have a 0 standard deviation, I can remove them because the 0 standard deviation means that the variable is no movement, right? So it will not have any impact on my target. What I was mentioning in that context is that from a regression perspective or from an efficiency of a particular variable in explaining or Y, or say in its impact on Y in a regression, if I'm going to run a regression afterwards, then it is probably a little premature to remove it from my scatter plot or heat map. Okay, the reason simply is that I can still do if I have a very strong domain understanding. The reason simply is that when we do find for multicollinearity, right, and the multicollinearity, the heat map or your scatter plot is not going to be the method of choice, or you are not going to use that to reduce multicollinearity. From that perspective, I'm saying in the post-model sense.
Okay, so that targeted analysis needs to be like done if we really feel like, say, suppose we don't have much domain knowledge or we don't have, so mathematically, then we go that way.
Go that way because then generally many cases in client data and services, what happens? So you will not have a lot of domain knowledge, right? So you will have some internet-driven domain knowledge, right? So from that perspective, in core industries like manufacturing or pharma, and you get a project, right, for example, and you will not be a pharma or manufacturing expert, right? So for you, I think it's important that you cannot do it that way. It's too big a risk, and you would ideally rather check for a variance inflation factor and take a more kind of statistically driven call.
So this inflation factor we can only take in the linear regression, right?
No, you can do in logistic regression also. Variance inflation is about your excess being multicollinear. So in logistic, the excess remains same, right? There is no change in the right hand side of the equation. It's mx plus c. You can do there
one,
also.
sorry, I think a little bit diverting from this topic here. So in inflation factor, you do 1 upon 1 minus r square, right? The r.
1 by 1 minus r square, yeah.
Yeah, so but we don't have r in the logistic regression.
This r is not that r, Mayank. This is not your regression r. This is your simultaneous equation r square from your regression among the x variables. You are not involving y here, right? Why will you take the r square for y here? It is not even relevant. You are trying to understand multicollinearity among your x's. I can show this to you in detail. There is a equations we form and we can actually decipher this equation you just said, no, 1 by 1 minus r square. But right now, I think we cannot because that will take also a bit of time. We can do at a later date, not a problem. You do your ML at some point, we'll do.
Yep.
Okay. Anything else? Anyone? All right. Seems nothing else at this point. If that is the case, we'll close for now. And yeah, we'll at some point definitely we'll catch up again. Okay. Thank you.
Thank you. Thank you so much,
Thanks, Mayank.
Thank you.
Thank you.
Thank you.
Thank you.
Thank you. Thank you.